This is a short video on how to do regression and correlation coefficient matrices in SPSS. So if we want to do a regression, the first thing we need to do is to make sure that the relationship is linear, right? So we can do a scatter plot, which I showed you how to do in another video. And then we also need to make sure it's an interval ratio variable. Remember that we really can't trust SPSS's classification of things over here. We really need to figure this out ourselves. We may need to do a frequency distribution, or with your data set, if you're more familiar with it, you may need to kind of think about how you measured that variable in your survey. So once we have those two preconditions met, we go up to analyze, we go down to regression, and we go to linear regression. So you notice all of the other different forms of regression that you could be doing, but we definitely always want to do linear. So we need to remember which one is our independent, which one is our dependent variable. If you notice, you can put in multiple independent variables. This is very different than doing that in, say, a t-test, where it'll spit out different t-tests for you. If you put in multiple independent variables, it will do multiple regression, which you do not know how to do, right? So we can only put in one independent variable. So say we're interested in looking at whether or not the number of brothers and sisters you have affect the number of children that you have. That's all we have to do. We just have to put in the independent and the dependent variable. And that's it. We click OK. And we get all of these different models, right? So the most important things we're going to look at are R up here, right, and R squared. We can comment for R on how the direction of the relationship and how strong it is. And R squared tells us what percent of the variation is accounted for by variation in the independent variable. We're not going to analyze ANOVA, though if you just used just sort of your general understanding of it, you would be able to see here's some sort of F test, right? And here's significance. This is a significant relationship. But you shouldn't worry about that too much because it's also reflected down here in the slope. Right, so this is our coefficients. In this column, if we're just doing single regression, which is what you are doing, this is A right here, 1.421, and this is beta, 0.122. So we can write our regression formula off of this column. We also, since we're testing this relationship between numbers of brothers and sisters and how many kids you have, we can, if we follow along here, this will test whether or not beta is 0. Right, we have to get this very large T, so we suspect that even though this is small slope, that we can be pretty certain that it's not 0. We can be pretty certain there's some relationship here, right? So this is all this is saying. It's very significant, right? 0.000. We can be very certain it's not 0, but it may not be strong, right? So we should remember that. It also may be that we're interested in exploring more this issue of how many children you have, and we just want to do some general analysis and exploration of the different variables that we have. So we can make a correlation matrix. So we go to Analyze Correlate, and we do bivariate correlations. And we can put as many variables as we want. This is very exploratory. Right? So we're like, oh, we'll just kind of do some data mining, do some exploring to see if there's any kind of relationship between all of these things and number of children. What it does is, it gets really messy. I think there's some problems with occupational prestige score, right? So this kind of mucked up our charts. Really, all of these should be filled in. But we do see that it shows us the correlation between number of children, number of brothers and sisters. It tells us whether or not that correlation coefficient is significant, which means it's testing whether or not it could possibly be 0. Right? And we also see there's a relationship here between highest year of school completed and number of brothers and sisters. So it's negative 0.315. And that's also significant. There's a number of different things here that are significant that I might want to look at. So if we try it again, just so you can get a better feel for the table without occupational prestige score, which when it comes up funny like that, it probably means there's some problem with how that question was answered. Really, your correlation coefficient matrix will look something like this instead. And you really only need to read half of it, this line of ones. The table kind of repeats itself, right? So it may be effective to literally put your hand over the screen to cover half of the table, just to not be as overwhelmed with all of these numbers. You can see there's lots of different kind of significant relationships between these different variables.